Well, good evening and welcome to Ratio Christi and welcome to week 2 of our annual symposium. This year we've decided to have it online because of the COVID restrictions and have been really privileged to put together a fantastic program with speakers from all over the world and also from Africa and South Africa. And we are going to be having 2 lectures this evening, which I think will be of interest to you. But thank you to all of those of you who are joining us live here on YouTube this evening. For those of you who don't know anything about Ratio Christi is a student campus ministry that began in the United States and now is now a global organization with chapters at universities across the world in various countries. And the ministry exists to serve Christian students and professors on campus by providing historical, philosophical, scientific and theological arguments and reasons for the Christian faith. The main purpose and goal of the ministry is to strengthen the faith of Christians in the academic arena, but also then to help us better understand the worldviews and ideas of those who don't share the Christian worldview, to engage them in meaningful conversation, and to provide an opportunity to share the gospel with those who do not know of Jesus and the forgiveness of their sins. And so we're an organization that deals with ideas and Christian apologetics, but we also are an organization interested in sharing the Christian faith in a compelling way. My name is Simon Brace. I am the National Director and Chapter Director at Northwest University. We do have 4 other chapters of Ratio Christi here in South Africa at Pretoria, Stellenbosch, and UKZN. And do check out our website. We have a website as well, a local South African website, ratiochristi.co.za. Please check it out. We have a lot of free resources available there and things you can download for free. And we also produce articles pretty much on a weekly basis that come out tackling all kinds of topics. And you can certainly avail yourself of those articles. And do also join us and subscribe to our YouTube channel, which where we've got a growing library of talks and interviews we've done with scholars from all over the world and from South Africa and Africa on all kinds of topics. And so do please help us by recommending Ratio Christi to young people, particularly high school kids and also students. But of course, this information is for everybody there. So if you've got people who've got questions and you find our material helpful, please feel free to recommend that to them. And finally, if you do feel led, we do ask for support financially. So consider supporting Ratio Christi as an organization and also praying for us as an organization. So that's an introduction to who we are. And let me take some time now to introduce our guest from the United States. Our guest speaker this evening is Casey Luskin. Casey, good evening to you.
Great to be with you guys.
Yes, it's good to see you. I've just in terms of my relationship with Casey, I've had the privilege of knowing him when I was actually working in the US. But Casey also spent a fair amount of time in South Africa and lived here for about 4 years, doing his PhD work at the University of Johannesburg. I'll just basically give you his formal bio. He is a scientist and attorney with graduate degrees in science and law, giving him expertise in both the scientific and legal dimensions of the debate of evolution. He holds a PhD in geology from the University of Johannesburg and a law degree from the University of San Diego. His BS and MS degrees in earth sciences are from the University of California, San Diego, where he studied evolution extensively. At Discovery Institute, he works as associate director of the Center for Science and Culture, where he helps direct the ID 3.0 research program and assists and defends scientists, educators, and students to freely investigate intelligent design. Dr. Luskin has been a California licensed attorney since 2005. He also co-founded the Intelligent Design and Evolution Awareness Center, a nonprofit for helping students to investigate evolution by starting IDA clubs on university campuses. He has published in technical law and science journals and has co-authored or contributed to multiple books, including Discovering Intelligent Design, Science and Human Origins, Theistic Evolution, a Scientific, Theological, and Philosophical Critique, and Debating Darwin's Doubt. Casey, it is a delight to have you together with us here, albeit you're on the other side of the Atlantic. But so good that you can take some time out to be able to do this important talk for us this evening.
Well, it's a lot of fun to be with you guys, Simon, and I miss all my friends in South Africa. Do you want me to share my screen now, or when should we?
Yeah, well, we can maybe launch into it, but maybe just to give some context for why we decided to pick this topic. Many South Africans are well aware that South Africa has a site here just outside Johannesburg called the Cradle of Mankind, and it is arguably has one of the most formidable and massive collections of human origins or discussions over anthropods and hominids. And a lot of evolutionary theorists put a lot of effort and research into these finds. And the question is, how do we as Christians, and how do we living today, mindful of evolution, think about something like the Cradle of Mankind? Casey and I had the privilege of visiting the Cradle of Mankind together when he was studying here at UJ, I think on 3 occasions. And so we've done pretty extensive tours around the facility and had lots of interesting conversations and discussions, and have toured with other scholars to look at the exhibits and to look at the material. And so this evening, because of the significance that Maropeng and the Cradle of Mankind has in South African academic work, we felt it important to address this question. And so Casey is going to put on his share screen now, and he's going to dive into the subject.
Just a moment here.
No worries. I'll let you know when you're coming up then, and then we can, I'll let you know.
Okay, can you see this?
Yep, there we go. You're good to go.
Okay, great. Well, again, Simon, thank you so much for the invitation to speak to your Ratio Christi South Africa group. And as you said, South Africa does have a very perhaps one of the most, if not the the largest and most prestigious collection of hominid bones in the world are found at the Cradle of Humankind, which is located just north of Johannesburg in South Africa. And it's really a spectacular place to go and learn about hominid fossils and learn about the evolutionary view of human origins. And so I hope to give you, I titled this talk, Human Origins and Intelligent Design, a South African Perspective, because I wanted to highlight some of the finds that have been made in South Africa, and also take a critical look at the way that this issue is promoted in your country. We'll get into that in more detail, but just know that if you are going to the Cradle of Humankind Museum at Maropeng, then you may perhaps get a sneak peek of what you will find there in this talk, and what to expect, and maybe some of the counter arguments. So let's dive in. So as Simon said, I lived in South Africa from 2016 until 2020. It was a great experience. My wife and I still dearly miss South Africa. We're Zooming with friends there on almost a daily basis. We're still involved with a lot of wonderful projects and ministries there. But we lived in South Africa from 2016 until when coronavirus hit last year. And we were told that we had about a week to get out, or we would have to leave the country, or we would actually get stranded, is what we were told. So we sold everything we had or gave it away in about a week's time in March of 2020 and made our way back to the US. But it was a very bittersweet time for us. But while we were there, I had many opportunities to learn about hominid fossils. Now, my PhD research at the University of Johannesburg, I should make clear, it did not have anything to do with studying hominid fossils, although I did have some opportunities to do sampling on the Cradle of Humankind for paleomagnetism, helping to date some of the fossils that are found there. But this, what you see in this slide here, is the Cradle of Humankind Maropeng Hominid Fossil Museum. It is really a spectacular museum if you've never been there. Clearly a lot of very qualified scientists put a lot of thought into this, and the architecture and the design is really amazing. I highly recommend going there. At the very least, if you want to be informed about what an evolutionary viewpoint says on human origins, you need to go to that museum, because if you want to respond to it, you need to first know what they're saying. So I'm very much encourage folks to go there. In fact, it's possible that there may be a visitor's guide that was written by myself with some help from Ratio Christi people, actually, that I'm sure Simon could pass on to you if you ever want to go there. So that's just a private, informal thing that we did for fun. The Cradle of Humankind, again, is one of the best hominid fossil sites in the world. In fact, it's safe to say that the whole field of paleoanthropology started through, in large part, through some of the research that was being done in South Africa. So this Meropeng Museum is going to make more appearances in this lecture. You're going to hear more about this museum, what's good about it, maybe some of the problems at that museum. I think you can learn a lot from that museum. Yeah, as Simon said, I did spend 4.5 years studying geology in South Africa. Here's my PhD thesis, which just recently got posted at the University of Johannesburg website. So if you really want to download all 636 pages, you can do that. I don't recommend reading it. It's pretty dry and not very exciting reading. But I looked at the early plate tectonic history of South Africa around 3 billion years ago through a group called the Pongola Supergroup that's based in southeastern South Africa in the KZN and Mpumalanga area. So let's get back to the Cradle of Humankind. Again, while I was in South Africa, I had many opportunities to learn about fossils from the Cradle of Humankind. I was able to go on a private tour of Dr. Robert Broom's workshop, where some famous fossils were found, such as Mrs. Pless and Littlefoot. And you can actually see where they're doing work on the bones in that workshop and see the site where those bones were discovered at the Cradle of Humankind. This is me doing paleomagnetic sampling at the Cradle of Humankind. You can see embedded in the wall here are actually big cat fossils. This is from Bolt's Farm, which is a fossil site at the Cradle. And we got to go there one time and help assist with the sampling of paleomag samples. These are the samples here in my right hand, and there's all of our notes. And it was a lot of fun, really great experience to be able to go into the Cradle and learn about, and see firsthand what some of the rocks look like and some of the fossils that are found there. Literally, this would be like a giant, a very large cat skull just embedded in the side of the cave wall. Really incredible stuff that you find there. And I want to say something that I want to dedicate this talk to Dr. Sue Dykes. Dr. Sue Dykes was a friend of Simon's and myself and many others in South Africa. She was another person who taught me immense amount about paleoanthropology. She emailed me right before I moved to South Africa in 2015, having no idea that I was about to move there. She'd read a book that I wrote called Science and Human Origins, or co-wrote, and I'll mention that book a little bit more later in this talk. And Sue got her PhD in paleoanthropology from the University of Witwatersrand at the Evolutionary Studies Institute there. And she is a she was, I should say, highly qualified paleoanthropologist who was a wealth of knowledge on this topic. And you know what? She was a skeptic of the view that humans evolved from ape-like creatures by purely Darwinian means. I don't think it's at all a misrepresentation to say that that's where she was coming from. Sue is a friend of mine. I heard her give lectures to this effect, and she taught me a lot. I don't know if Sue would agree with everything I'm going to say in my lecture, but I would say that I want to dedicate this talk to her. She passed away suddenly in 2019, and she was a friend to many of us, really somebody who was respected by folks, I would say, on all sides of this issue, and she's very dearly missed. So I want to dedicate this talk to her. So an outline of where we're going to go in this talk today. We're going to first go over an evolutionary view of human origins, because again, if you want to critique something, you first need to understand it. So let's understand, what is the standard evolutionary view of human origins and what are they saying? We'll then look briefly at what makes humans unique, what makes us different from ape-like creatures and some of these hominid species. And we'll talk about whether or not the features that make us unique, both morphologically and genetically speaking, have enough time to evolve, given the, say, 5 to 8 million years that are allowed by the fossil record since our most recent common ancestor that we shared with chimpanzees. We'll then look at the field of paleoanthropology and talk about how it is fragmented in multiple senses. We'll then look at some of the actual hominid fossils themselves. We'll talk first about some of the early hominins. We'll talk then about the Australopithecines. We'll then look at certain fossils that are claimed to be intermediates between the Australopithecines, which are very ape-like, and human-like members of the genus Homo. In fact, some of these intermediates are from South Africa. So we'll talk about those fossils, and you probably have heard of many of these. They've been in the news a lot, and some of these famous fossils, and whether they actually show sort of an intermediate between the ape-like Australopithecines and modern humans or human-like members of the genus Homo. We'll then talk about the origin of our genus Homo. We're the species Homo sapiens. That's genus Homo, species sapiens. And we'll talk about how it appears abruptly in the fossil record in what some have called a Big Bang type of origin. We'll talk briefly about the idea of human exceptionalism and what it means. And then finally, we'll look at the various species that belong properly within the genus Homo and how similar they are and how they're really very, showing a small degree of what I might call microevolution. And again, if you want references, I'm going to provide a lot of references in this talk, but if you would like more references, there are 2 books where I've written about this in great detail. One of them is Science and Human Origins, and the other is the book Theistic Evolution. And I'll give the reference for that at the end of this lecture. So I'll make you watch to the end to get that one. But if you want many of the technical references, you can get that from these books, or you can email me and I'm happy to provide them. So what is the evolutionary view of human origins? Well, in 2009, I had the opportunity to testify before the Texas State Board of Education. There was the debate in Texas about whether students would learn about both the scientific evidence for and also against Darwinian evolution in public schools in the state of Texas. And Texas is very big, so it has a lot of students. It's very influential at a nationwide level here in the US about how evolution is taught. And I was sitting there watching other scientists who were testifying, and one of them was a anthropology professor at Southern Methodist University, Dr. Ronald Wetherington. And Professor Wetherington got up and testified against teaching students about the weaknesses in evolution. In fact, when he testified about human origins, he made it sound as if all of the evidence is there. There are really no major questions left to resolve as far as how humans evolved from ape-like creatures. And the fossils show sort of this nice, neat evolutionary lineage without any problems whatsoever. So he said that, and this was from his direct testimony to the Texas State Board of Education. He said, human evolution has, quote, arguably the most complete sequence of fossil succession of any mammal in the world. No gaps, no lack of transitional fossils. So when people talk about the lack of transitional fossils or gaps in the fossil record, it absolutely is not true. And it is not true specifically for our own species. And he went on to say that human origins provides a nice, clean example of what Darwin thought was a gradualistic evolutionary change. So there's this idea that there are these, sort of ape-like precursors. We didn't evolve from apes. Apes are living creatures, but these ape-like hominids in the fossil record. And there's this gradual progression from those creatures to modern humans in a gradual sequence that shows no lack of transitional fossils and no gaps whatsoever. And I was sitting there watching Professor Wetherington, and he seems like a very honest, decent guy. And I'm sure that he believes every word he said was true. So I'm not accusing him of doing anything wrong or saying anything that he believed wasn't true. Certainly not accusing him of anything like that. But what I would say is that I had read a lot of peer-reviewed papers in this technical scientific literature about human origins. And I knew that there was a very different story that was being told in the technical literature that admitted that that there were large gaps in the human fossil record, and that there were serious problems with trying to connect modern humans to an ape-like lineage leading back to, some kind of ape-like ancestor that we shared with chimpanzees. And I knew that what he was sort of promoting to the Texas State Board of Education was what I would call this dumbed down, this sort of oversimplified version of human origins that we see in textbooks, that we see in National Geographic documentaries, that we see in museums, as you'll see as we talk about what's in some of the museums in South Africa. And I knew that this is really not an accurate description of what the scientific evidence really says and what the technical literature says. So I then really wanted to go and research this issue more. And this is what helped, I would say, inspire me to write the chapter in Science and Human Origins a few years later, and then continue writing about this topic over the last few years and even up until today. So what is the evolutionary view of human origins? Well, it starts off we'll say between 5 to 8 million years ago with the early hominins, which are supposed to be very close to the common ancestor that we shared with chimpanzees. Some of these early hominins that stood at the beginning of the human lineage would be Sahelanthropus chidensis, or Auroran tugensis, or Ardipithecus ramidus. These are supposed to be some of the first upright walking species that branched off the lineage that led to chimpanzees and instead took evolution in a different direction, leading towards the branch that supposedly led to human beings. And then a few million years later, we get the Australopithecines. They're supposed to be about 2 to 4 million years old, maybe 2 to 4.5 million years old. And in many respects, they were ape-like. We'll get into this in more detail. And then the Australopithecines gave way to the genus Homo around somewhere between, we'll say, 2 to 3 million years ago. And the genus Homo is basically, that's our genus. So that's supposed to represent the evolutionary origin of modern human-like forms in the fossil record. And some well-known species there would be Homo habilis, Neanderthals, Homo erectus, and of course, our species, Homo sapiens. And so there's this phylogeny, this evolutionary tree that supposedly shows this progression from early hominins through the Australopithecines to early members of the genus Homo up through modern humans. And the question is, are there fossils that document this story? So what we're going to see is that hominid fossils generally fit into 2 categories, and that would be ape-like species and human-like species with a large unbridged gap between them. And the fossil record does not document the evolution of humans from ape-like precursors. So let's first define a term or two. What is a hominin or hominid? Well, a hominin or hominid, we're going to use those terms interchangeably. Unfortunately, those terms are used inconsistently in the technical literature. Some folks will use the term hominid to refer to any member of family Hominidae, which includes human beings, but also the great apes like chimps, gorilla, and orangutans. So some technical papers will use the term hominid to refer to any member of the great apes or humans and all of our ancestors going back to our most recent common ancestor. But another way the term hominin or hominid is used is to refer to any member of the branch that eventually leads to modern humans after it branched off our most recent common ancestor with chimpanzees, okay? So basically any member of this line here, this branch of the tree, is called a hominid or a hominin. And we're gonna use the term hominid or hominin in that sense in this talk today, just for clarity's sake. But I just wanna recognize the term is used sometimes differently in the literature, can be a little bit confusing, but we're gonna use it this way today, which is a very, very common accepted way of using the term. So what makes humans unique from these hominid or ape-like or even chimpanzee species? Well, in this diagram, which is from a 2004 paper in the journal Nature, humans, which are A and C, and Australopithecines, E and F, and then chimps, which are B and D, have significantly different shoulders, rib cages, pelvises, hips, legs, arms, hands, and feet, each appropriate for different modes of living. And chimps are adapted essentially for life in the trees, whereas humans live on the ground where we walk and we run. So the question is, what changes would be necessary to convert an ape-like creature into a human-like one? Well, first you would need a new design of the spine, a new shape and tilt to the pelvis, legs that angle in from the hips, knees, feet, and toes designed for upright walking, a skull that sits on top of the spine in a balanced position, a shift in jaws and muscle attachments, a face that is flattened with sinuses behind the face and the eye sockets located in different places to permit a forward gaze. And this paper from Nature in 2004 counted 16 anatomical changes necessary to convert an Australopithecine, our supposed hominid ancestors, into a member of basically the genus Homo that looked like us. Now, the problem for evolutionary theory is that each of these features probably required multiple changes for it to originate. And basically to give some useful functional advantage to an organism. So the question is there enough time to get these changes by a blind and unguided neo-Darwinian process of random mutation and natural selection? So this brings us to, there's a lot of changes to make, so much to do, but there's only so much time. We'll say 5 to 8 million years from our most recent common ancestor with chimps. And that may sound like a lot of time, 5 to 8 million years, but when you start to do the math, you realize that what we call the probabilistic resources are highly limited in terms of what can be accomplished through an evolutionary mechanism through blind unguided evolution in that time period. The probabilistic resources are related to the number of individuals in the population, the mutation rate, and the generation time. And the more resources you have, the faster the evolution can go. But let's talk about what happens when you have to evolve complex traits. So we can compare evolving a complex trait to opening a padlock on a bike. Okay, so let's say that you have a padlock that only requires one digit to be the right digit in order for the padlock to open. So you basically have, 10 chances to get the number right. Well, a 1 in 10 chance of opening the lock is pretty good. You can probably get that lock open pretty quickly, right? This would be analogous to maybe a trait that only requires one single mutation before it gives you an advantage. A trait like that is actually probably likely to arise by Darwinian evolution. It's not difficult for one single mutation to occur in a population and then get spread and fixed throughout it. But what about a padlock that requires 2 digits? You have to get both digits right before the lock will open. It's not enough to just get one digit right. You have to get both right or the lock won't open. Well, now your odds of getting the lock open by chance are 1 in 100. So you can see that the odds are starting to go down at an exponential rate. 1 digit is 1 in 10, 2 digits, 1 in 100, and then 4 digits, what is that? It would be 1 in 10 times 1 in 10 times 1 in 10 times 1 in 10, or 1 in 10,000. So as the number of digits that you need to get right to open the lock go up, the likelihood of you finding the right combination by chance go down. And in the same way, when you need more mutations to be present before getting some advantage, the likelihood that you're going to be able to get all those mutations present in a single organism so that trait can evolve, the likelihood goes down at an exponential rate. With each new mutation you need, you start to have what's called combinatorial inflation. The number of trials you need goes up at an exponential rate, and your likelihood of getting that just right combination goes down at an exponential rate. So the odds of opening by chance decrease exponentially as the number of digits in the combination increase. So this can be again analogous to what we call a multi-mutation feature, which requires multiple mutations before conferring any advantage. As more mutations are required, the odds of the feature appearing decrease exponentially, and this quickly exhausts your probabilistic resources. So are there sufficient chances or probabilistic resources to convert an ape-like creature to human-like one, even in the, say, 5 to 8 million years that are available? And again, our probabilistic resources would be our population size, the number of individuals in the population, generation time, how long does it take for this species to reproduce? If it reproduces very rapidly, things can evolve more quickly. If you have a larger population, you have more trials, more opportunities to get all those mutations you need. So things have a better chance of evolving. The mutation rate, a higher mutation rate also gives you more mutations, a better chance of evolving. And then of course, another issue is the time available from the fossil record. We'll say it's less than 10 million years. I think everyone agrees that the most recent common ancestor that we shared with apes lived less than 10 million years ago. So if we talk about things, we already talked about some of the morphological or body structure changes that are needed, but what about genetically speaking? Well, a paper in the journal Science a number of years ago just looked at that quote unquote 1% difference between human beings and chimps. Now, of course, it is now known that our DNA is greater than 1%. But if we just assumed that our DNA was only 1% different, well, it turns out that that amounts to 35 million individual base pair changes in our DNA. 5 million indels, those are larger sequences that are inserted or deleted into our DNA compared to chimps, as well as 689 full extra genes in humans that are not found in chimps. So that's a lot of DNA. And we can ask the question, let's just say that there's some trait that only requires 2 out of those 35 million base pair differences. Only 2 mutations have to be present for that trait to arise and give you some advantage. Well, a few years ago, Michael Behe and physicist David Snoke performed computer simulations and theoretical calculations that asked what it would take to get 2 mutations to become fixed in a population of animals. And they modeled the evolution of a functional bond between 2 proteins. But we could say, we're looking at some new trait arising in chimpanzees or human beings or our ancestors that requires just 2 mutations to be present before it gives some advantage. And it turns out that if you look at the number of mutations required and you set that at 2, that the amount of time or the population sizes that were required just to generate a trait that requires 2 mutations before giving an advantage in humans would be very difficult for that to evolve. In fact, if more than 2 mutations are necessary to produce a functional advantage in any multicellular organism, then it's very unlikely to arise in any reasonable timescale. In fact, what's funny is that Behe and Snoke's critics tried to refute them in the journal Genetics. And they looked at the Darwinian evolution of simply 2 mutations, a trait that requires 2 mutations to be present before giving any advantage. And they said that to obtain only 2 simultaneous mutations via Darwinian evolution, quote, for humans with a much smaller effective population size, this type of change would take more than 100 million years. And they admitted that this is very unlikely to occur on a reasonable timescale. So what we're seeing here is that if you need multiple mutations to be present before you get some advantage, if any of those 35 million base pairs that we're different from chimps entail some trait where 2 or more mutations are required to give us some advantage, then that trait is very unlikely to evolve in the mere 10 million years that are allowed in the fossil record. And this has to do with the fact that the effective breeding population size in our human ancestors is very small, maybe just at most, according to Darwinian theory, a few thousand individuals. We reproduce very slowly, say 5 to 10 years. And when you count the number of generations available, you don't have enough in that 10 million year time period for that to happen by unguided Darwinian evolution. So this casts grave doubt on a Darwinian origin for the human species. The mathematics simply makes it impossible. There's not enough time in humans to evolve a multi-mutation feature requiring merely 2 mutations before giving any advantage. And again, you look at all these different traits and the genetic differences that are needed to convert an ape-like creature into a human-like one. And if any of these differences would require more than 2 mutations before providing an advantage, it's very unlikely to evolve in humans since our split with apes some 6 million years ago. So in light of these mathematical barriers, we can ask, well, do we see sort of this gradual evolutionary buildup in the fossil record, what Darwinian evolution predicts? And the answer I would say is no, and we'll get into that right now. So the fossil record is consistent with the math. The math says that a gradual, 1 mutation at a time origin is very difficult for Darwinian evolution to accommodate. And that is also confirmed by what we see in the fossil record. So let's talk first about the field of paleoanthropology and how it is fragmented in multiple senses. Well, the field of paleoanthropology is simply the field that studies human origins in the ancient prehistoric past. And I would say it's fragmented in 3 senses. Number 1, the fossils themselves are fragmented. Number 2, the record is fragmented in space and time. And number 3, the field is fragmented. Well, let's talk about this. Stephen Jay Gould famously said that most hominid fossils, even though they serve as a basis for endless speculation and elaborate storytelling, at the end of the day, he says that they are fragments of jaws and scraps of skulls. So we really have a difficult time finding complete fossils. Occasionally we do, but typically we don't. There was an article in the journal Science a number of years ago, which talked about the overall number of bones that have been found in the field of paleoanthropology. And it said that the primary scientific evidence is a pitifully small array of bones from which to construct man's evolutionary history. One anthropologist has compared the task to that of reconstructing the plot of War and Peace with 13 randomly selected pages. Conflicts tend to last longer because it is so difficult to find conclusive evidence to send a theory packing, because the data set is just so small, you can't say, oh, you're wrong. So I understand that these quotes are somewhat dated. They're from the early 1980s. I was alive then, I'm not ashamed to admit, but I think that these quotes still hold true. I think that there is still a very small amount of data in the field of paleoanthropology compared to many other fields as far as what we can construct the evolutionary history from. And so to illustrate, trying to reconstruct the plot of War and Peace from 13 pages, I took the cover of War and Peace and broke it up into just 13 little dots. And if that was all you had, there's no way that you could reconstruct the cover of that book. It would be impossible for you to do. And I think that that is part of what's going on with human evolutionary history, that we have very little data to go on. And so, a lot of these claims about human evolution, we can ask whether they're very well supported by the evidence. So the fossils themselves are fragmented. The record is also fragmented. Richard Lewontin, who just passed away, he was at Harvard University. He said, when we consider the remote past, before the origin of the actual species Homo sapiens, we are faced with a fragmentary and disconnected fossil record. Despite the excited and optimistic claims that have been made by some paleontologists, no fossil hominid species can be established as our direct ancestor. So the record is fragmented. We don't have a clear and neat fossil record in paleoanthropology. I would also say that the field is fragmented. This is one of my favorite quotes. It was from a PBS Nova producer who was doing a documentary on Neanderthals. And he said that each Neanderthal expert thought the last one I talked to was an idiot, if not an actual Neanderthal. So I found this very amusing because what he's saying is that there's a lot of acrimony and strife within this field. In fact, when you read books by paleoanthropologists, they will regale you with tales of how, this lab wouldn't share its data, or that lab wouldn't let me see the bones, or I couldn't get access to this site, or, this lab is doing shady business. There's a lot of you could say personal acrimony in the field of paleoanthropology, which makes it interesting, but at the same time, it doesn't always give you confidence that you're dealing with a perfectly objective scientific field. But don't just think that because science said it, that settles it. These are human beings. I'm not saying they're bad people, but they're human beings, and they're subject to normal human pitfalls, which we all are subject to. So the field of paleoanthropology is also fragmented. In fact, a number of years ago, senior Nature editor Henry Gee said that fossil evidence of human evolutionary history is fragmentary and open to various interpretations. And I would say that, is one of the interpretations that we're open to the interpretation that humans did not, in fact, evolve from ape-like creatures. And I think that if we're not open to that interpretation, then we're not really letting the evidence speak for itself. And we're forcing ourselves to be wedded to predetermined conclusions about what the evidence has to say. We have to at least be open to the possibility that humans did not evolve from ape-like creatures. And if we are open to that, then I think we can follow the evidence where it leads and see if it goes in a different direction from the mainstream view. So let's dig more into the fossils, talk about early hominin hype. Around the year 2000, there was a fossil discovered called Aurorantugensis, or Millennium Man. And immediately the fossil was hailed as a human ancestor. The New York Times said fossils may be earliest human link. But what was actually found was kind of like what Stephen Jay Gould said. It was just a few scraps of bones. They did actually have part of a femur here, which is very exciting. That's actually extremely rare in hominid fossils. But the reality is what they found was just a few scraps of bones. And even though this fossil was described as potentially the first upright walking species to diverge from the line that led to apes, a few years later, there was a chapter in Yale University Press book that said, all in all, there is currently precious little evidence bearing on how Auroran moved. And this sort of takes us to the first example of what I think is a common arc in the media rhetoric over hominid fossils when they're discovered. When a new hominid fossil is discovered, the media will initially see this as a great opportunity to launch a new campaign or crusade to evangelize the public for Darwin. And so you'll see these media stories saying, oh, a new human ancestor found, missing link solved, et cetera. They'll say things like that. But then wait a few months. And what ends up happening is cooler heads will prevail and papers will come out in the scientific community that basically will say, you know what, there's more to the story than what the media initially said. We don't believe the hype. We think that actually maybe this was not a human ancestor. And invariably that's what happens. That the evidence comes out that it was not quite as exciting for an evolutionary view as the media made it out to be. And so another example of that would be Ardipithecus ramidus, which was first unveiled in the year 2009. Discovery Channel said, Ardi, oldest human ancestor unveiled. Associated Press, world's oldest human link skeleton found. 2009 journal Science, breakthrough of the year. Lead Ardi researcher at UC Berkeley called Ardi the, quote, Rosetta Stone for understanding bipedalism. Bipedalism, of course, means just the ability to walk upright. And so he said that Ardi would help us understand how bipedalism evolved in our ancestors in our species. Well, it turns out that the initial condition of Ardi's fossil was far from good. In fact, there was an article in Time magazine which said that some portions of Ardi's skeleton were found crushed nearly to smithereens and needed extensive digital reconstruction. Well, the problem is that bones like the pelvis are highly important for understanding how an organism walked and whether it walked upright. And so if a bone like the pelvis is initially crushed nearly to smithereens and was digitally reconstructed, that does not necessarily give you a confidence that this was just an objective reconstruction. How do we know that there aren't biases and pre-conclusions that are influencing how we reconstruct a fossil like this? In fact, one article said that the pelvis initially looked like an Irish stew. Okay, again, that does not inspire confidence that we knew exactly what this fossil looked like. Elsewhere it was described as roadkill, squished, chalky, distorted, again, crushed to smithereens. So this is not sort of, an ideal situation for a fossil to be found in. And of course, as I said, eventually cooler heads did prevail. There was an article in the journal Science that said that all of the Ardipithecus ramidus bipedal characters cited also serve the mechanical requisites of quadrupedality. In other words, it didn't have to be a biped, it could have been a quadruped that walked on all fours. And an article in Nature said the claim that Ardipithecus ramidus was a facultative terrestrial biped is vitiated because it is only based on highly speculative inferences about the presence of lumbar lordosis and on relatively few features of the pelvis and foot. And so basically these papers in some of the top journals, Science and Nature, are saying we're skeptical of this claim that Ardi necessarily represents a human ancestor and that it was a biped. It might have been something else. In fact, the author of the Science paper said that the hype around Ardi was overblown. And I think that was a common sentiment. And just a little postscript here, a paper that was published earlier this year in 2021 found that Ardi had the hands of a tree climber and a knuckle walker, basically a chimp-like mode of locomotion. So again, that, in my opinion, does not count towards it being a human ancestor. It certainly counts against that. But the hype doesn't necessarily go away. Even though in 2002, this is not new information. I'm sorry, actually, this is out of sequence here. So we'll talk about Sahelanthropus chidensis, which is another species that was found around the turn of the millennium. It was found in the country of Chad. And again, it was initially linked to being, sorry, my phone is ringing here and it just threw me off. It was initially linked to being a human ancestor, but even in the year 2002, an article in the journal Nature said that many features link the specimen with chimpanzees, gorillas, or both to the exclusion of hominids. Sahelanthropus was an ape. Well, 2014, Bill Nye, the science guy, many of you have probably heard of him. He said that fossil hunters have found a whole range of human ancestors, including Sahelanthropus chidensis. Every one of these is a no longer missing link. So he's claiming that it was a human ancestor, even though, Journal Nature 2002 is saying, no, this fossil was an ape. So you can see that the hype can take a long time to go away sometimes. Just last year, the femur of Sahelanthropus was compared to a chimp-like body plan, and they found that it was basically chimp-like. And a German paleoanthropologist said it's more similar to a chimp than to any other hominin. So that does not point toward its being a quote unquote, as Bill Nye put it, missing link. There was an ancestor of human beings. So as we saw in the original phylogeny, that after the early hominins, we then had the Australopithecines appearing. So who are the Australopithecines? Well, their name literally means southern ape. They lived about 1.9 to 4.5 million years ago. Their brain and body were about the size of a chimpanzee. And the most complete and most famous known Australopithecine specimen is Lucy, which I'm sure many of you have heard of, and it's a member of Australopithecus afarensis. Now, Australopithecines are often described as sort of an chimp-sized creature with a human-like brain that was sort of capable, sorry, not a human-like brain, a chimp-sized creature with a chimp-sized brain, but which was nonetheless capable of upright walking and a human-like mode of locomotion. But there are many Australopithecine traits that are either ape-like and or not human-like, including their arms, their chest, their striding gait, their shoulders, their abdomen, their inner ear canals, which you might not think is important, but inner ear canals are related to the way you walk. And it was found that Australopithecines had inner ear canals like a modern-day ape. Their developmental patterns are ape-like. Their toes and teeth are ape-like. Their hand bones are ape-like. In fact, it was found that Lucy had the hand bones of a knuckle walker, and their brain size was also ape-like. So I would say there's a lot more going on with Lucy than her sort of being like a small-brained bipedal ape. Again, she was small-brained, but the bipedality is controversial. Her hand bones showed that Lucy, this is from the journal Nature, that she knuckle walked as chimps and gorillas do. So that's certainly not good evidence that she was bipedal. The journal New Scientist said that everything about her skeleton, from fingertips to toes, suggests several traits that would be very suitable for climbing in trees. The American Journal of Physical Anthropology found that Lucy's pelvis, again, very important for whether she walked upright, was initially badly crushed, with distortion and cracking, kind of like already it had to be reconstructed. So Lucy's pelvis is not necessarily telling us, a clear story of how she walked. In fact, the Journal of Human Evolution said that there is error in the reconstruction of the pelvis, creating a very human-like sacral plane. And it said that prevailing views of Lucy's posture are almost impossible to reconcile. To resolve such differences, more anatomical fossil evidence is needed. The available data at present are open to widely different interpretations. So basically, they're saying we don't have enough evidence from Lucy to understand if she really walked upright or not. And Bernard Wood, who's a leading paleoanthropologist, said that Australopithecines are often wrongly thought to have had a mosaic of modern human and modern ape features, or worse, are regarded as a group of failed humans. And he says Australopithecines were neither of these. Interestingly, an article in the Journal of Molecular Biology and Evolution looked at the members of Australopithecus, and that would be here on the right. That would be, I believe, Lucy's species, actually. And then on the left, we see some of the earliest members of the genus Homo, like Homo erectus. And they compared the two and asked if there are intermediates between this ape-like species and this human-like species, which again, there's questions about whether Lucy really walked upright. We'll leave that alone for the moment. But they said that no gradual series of changes in earlier Australopithecine populations clearly leads to new species. That's early Homo. And no Australopithecine species is obviously transitional. A paleoanthropologist from the UK, Leslie Aiello, said that Australopithecines are like apes and the Homo group are like humans. Something major occurred when Homo evolved, and it wasn't just in the brain. So there's major morphological and also, I would say, cognitive changes going on during the supposed evolution from Australopithecines to Homo. But as you saw, there's not intermediate forms showing how those differences evolved. So let's talk about some of these supposed intermediates that are supposed to bridge the gap between the ape-like Australopithecines and the human-like members of the genus Homo. And we'll talk specifically about some intermediates from South Africa. But first, we'll talk about Homo habilis, which has been called a link between ape-like creatures and human-like creatures. Well, again, there's a lot of criticism of that view. The journal Nature said that the habilis skull represents an unlikely intermediate between the morphology seen in Australopithecines and Homo erectus. The Journal of Human Evolution said, it is difficult to accept an evolutionary sequence in which Homo habilis, with less human-like locomotor adaptations, is intermediate between Australopithecus and fully bipedal Homo erectus. So basically, they're saying that actually they found, I believe, that Homo habilis was more similar to Australopithecines than it was to modern humans. Ian Tattersall calls Homo habilis a wastebasket taxon, little more than a convenient assortment, convenient recipient for a motley assortment of hominin fossils. Now, I'm willing to grant that this species actually exists, but what about the claim that it was a tool user? In fact, the name Homo habilis means handyman. Well, I mentioned earlier that I'd been to the Meropeng Museum there, just north of Johannesburg at the Cradle of Humankind. And while I was there, I'd often take photos and go back and then fact check the claims at the museum. And here's one example of a claim at the museum that I think is not supported by the evidence. They say that the earliest species of the genus Homo, Homo habilis, or handyman, appeared about 2 million years ago in Africa. They say that Homo habilis had smaller teeth and a larger brain and was probably the first hominid to make stone tools, including pebble choppers and shark flakes of stone. So do we see evidence that Homo habilis actually made these tools? The answer to that is no. You hear this claim all the time that Homo habilis was a tool user, but there's literally zero direct evidence for that claim. It's just part of an evolutionary narrative. And in fact, an article in the journal Science a few years back said that the association between Homo habilis and tools has proven highly dubious. And it says that the main motivation for calling Homo habilis genus Homo was from Richard Leakey's desire to identify this hominid as the maker of simple stone tools found in the lower layers of the Olduvai Gorge, following the dictum of man the tool maker. Okay, so it sort of was following an evolutionary narrative. That's why they associated this fossil with tools, even though there's no direct evidence that Homo habilis used tools. And in fact, a study a few years ago found that across the board, habilis had Australopithecine-like traits, not Homo-like traits. So it's been misclassified as Homo. It really should be probably Australopithecus habilis. And so without it, we're again left with a major discontinuity or break between the Australopithecines and the genus Homo. Well, in 2015, it was hoped that maybe they'd found a fossil that could bridge that gap. And that was Homo naledi, which was an incredibly rich trove of fossils that was found at the cradle of humankind and reported in 2015. And again, the media went nuts. They were promoting Homo naledi as the new human ancestor. They said, CNN, Homo naledi, new species of human ancestor discovered in South Africa. Daily Mail, scientists discover new skull of human ancestor, Homo naledi. PBS, trove of fossils from a long lost human ancestor. And they're right. It was an impressive collection of bones. In fact, it was the largest ever found. And this is very exciting and it's wonderful for the field of paleoanthropology. But get to the details and don't just believe the media hype. Read the technical papers, the commentary by experts, because they tell a different story. So first of all, the hands of Homo naledi were unique. The hand showed a unique combination of anatomy, including unique first metacarpal morphology and long curved fingers, which suggest that naledi was, unlike humans, well suited for climbing and suspension. The foot differs from modern humans in having more curved proximal pedal phalanges and features suggestive of a reduced medial longitudinal arch, giving it an overall unique locomotor repertoire. Again, unlike humans, it was likely comfortable climbing in trees. So the lead Homo naledi researcher, Lee Berger, said in the New York Times that the species is quite different from anything else we have seen. So basically the species looks like it was unique. But there are a number of controversies over Homo naledi. First controversy was, did it bury its dead? There was claims that were made that Homo naledi did in fact bury its dead. However, burying dead in the cave where it was found would have required shimming through a very steep, narrow crevice while dragging a body a long distance in the dark, a physically challenging task for any hominin of any level of intelligence. And many scientists, including two of Lee Berger's colleagues at the University of Witwatersrand, dispute this intentional burial hypothesis. And in fact, one of them said, or one scientist said, that their explanation of Homo naledi repeatedly carrying in their dead into this cave over the years and putting them in the chamber is torturous and incredible. So they're very skeptical of the claim that Homo naledi was showing signs of culture and intelligence by burying its dead. What about the genus Homo? Does Homo naledi belong in the genus Homo? Well, given the species' small brain and Australopith-like pelvis and trunk, its placement within Homo has proven controversial. Ian Tattersall writes that naledi possesses an unusual combination of morphological attributes, which seem to align more with the Australopiths than with any member of Homo. Again, back to the Maripan Museum, it was claimed that Homo naledi has this flattened face that is like a human. But look at this. This is a photo of the the way that they displayed this skull right there on the table in the Maripan Museum. And even though they claimed that it had a human-like face, the jutting jaw of Homo naledi, seen in the left photo here, is ape-like and strikingly different from the flat face of modern humans, contradicting the museum's claim in the photo that the overall shape of the skull is most similar to other members of the genus Homo. I don't necessarily think that is true. What about the age of Homo naledi? Well, Homo naledi's promoters initially suggested that it was between 2 to 3 million years old, but that date was never the result of any geological analysis. It was driven strictly by evolutionary considerations. And in 2017, they actually did produce a geological date of the fossil. And it turns out that it is 1/10 of the age that they wanted it to be based upon evolutionary considerations, only 250,000 to 300,000 years old. So the evolutionary prediction about the age of this fossil was wrong. Why did they want Homo naledi to be 2 to 3 million years old? Because that is precisely when they think that modern Homo evolved from the ape-like Australopithecines. But there are no, as we'll see, there are no fossils documenting that evolutionary transition. So they were hoping that Homo naledi could plug that gap, but it's far too young to be a human ancestor and far too young to be living in that time period when the genus Homo supposedly evolved. So is it a transitional form or an ancestor? A 2016 study found that naledi's place within Homo is ambiguous and concluded that naledi does not appear intermediate between Australopithecus and Homo. The discoverers called it a unique mosaic previously unknown in the human fossil record. In the parlance of evolutionary biology, a mosaic, by the way, usually means a fossil that has a suite of traits that are difficult to fit into the standard evolutionary tree. That's sort of code language in evolutionary biology for something that is not a good fit to the standard evolutionary tree. So I think when we see the word mosaic applied to Homo naledi, it means that it's not plugging an evolutionary gap that we want it to plug. It looks different. So even though the Maripang Museum asks if Naledi was almost human, I would say it's very different from modern humans. And it certainly does not, I don't believe that it warrants placement within the genus Homo. Now, what's interesting is that in the year 2010, many of the same scientists who discovered and promoted Homo naledi were promoting a different intermediate or ancestor du jour. And it was also from South Africa, and that was Australopithecus sediba. Again, lead discoverer Lee Berger said that Australopithecus sediba makes a very good candidate ancestor for our genus Homo, for human beings. But there's a problem. Much like Homo naledi, which postdates the appearance of the genus Homo by some 2 million years, Australopithecus sediba postdates the earliest evidence of Homo by 100,000 years. But so what? There was an article in the South African Journal of Science that said, look, on temporal grounds alone, one cannot dismiss the possibility that Australopithecus sediba could be ancestral to the genus Homo. Why are they saying this? Even though it appears 800,000 years after its supposed descendants. Well, the idea, whenever evolutionary biologists are confronted with what we might call a chronological inconsistency with compared to the ordering of fossils in the fossil record with what they want their evolutionary model to say, what they will do is they will just invent what are called ghost lineages. Ghost lineages are where you say, well, look, this fossil appears at this time, but maybe its lineage extends much further back in time. It's a ghost lineage because we have no actual hard evidence for it. But we're going to assume, excuse me, that the fossil record is just incomplete. It didn't preserve these fossils. And so we can make the fossil record fit evolutionary theory by just inventing ghost lineages whenever necessary to accommodate these chronological inconsistencies. Well, finally, about 2 years ago, I was very happy with this paper because it finally tested this practice of inventing ghost lineages to simply resolve evolutionary conundrums. And what they did is this study asked, what is the likelihood that Australopithecus sediba is ancestral to the genus Homo, given that it appears some 800,000 years after the genus Homo appears in the fossil record? And they looked at all of the supposedly known ancestor and descendant relationships among hominid fossils. And they then plotted them on a histogram, plotting the difference between the supposed ancestor's age and the supposed descendant's age. And the reality is, in most cases, the ancestor does become the descendant. But they found that if you plot up this histogram and fit a nice Gaussian curve to this data, that the likelihood that a fossil would be 800,000 years younger than its supposed descendants is less than 0.001. So in other words, the likelihood that sediba is ancestral to Homo is less than 0.001. And just for fun, I decided to ask, well, where would Homo naledi plot on this? Because it still claims sometimes that Homo naledi is our ancestor, and there's just some, imaginary ghost lineages that takes Homo naledi back another 2 to 3 million, 2.5 million years in the fossil record, so it could be ancestral to the genus Homo. So if we were to say Homo naledi now has a differential of 2.5 million years, it appears 2.5 million years after its supposed descendants. And I don't even know what the p-value would be here, but it would be much less than 0.00001. I mean, it'd be very, very small. So you can see that the likelihood that these species could serve as intermediates between the ape-like Australopithecines and the genus Homo is virtually nil. And there's also a problem because certain key traits are evolving in the wrong direction. Turns out that Australopithecus sediba had a more Homo-like pelvis, teeth that were surprisingly human, and hands that were very human-like. But Homo naledi, those traits are actually less human-like than they are in Australopithecus sediba. Its pelvis was Australopith-like. Its teeth are primitive, and its hands were curled fingers that were Australopith-like. So the problem is that key traits are evolving backwards, according to this evolutionary lineage that has sometimes been put out there, that we had Australopithecus sediba, which then was an ancestor of Homo naledi, which then was an ancestor of modern humans. That doesn't make any sense because key traits are evolving backwards. And according to standard cladistics analysis, they really should not be human ancestors in the same evolutionary lineage. It doesn't make sense unless you have a lot of reversals. This is not a very parsimonious tree. It does not make for a very clean evolutionary story. So if sediba is not our ancestor, then we have what I call retroactive confessions of evolutionist ignorance. Because when sediba was first reported, when people think that they've finally solved some problem, then they admit that the problem was there and it was a really big deal all along. But it's often not until they think that they've solved some problem that they will have these sort of retroactive confessions of ignorance that, oh, well, we didn't know how this worked, but now we solved it. They won't say that until they actually think they've solved the problem. But if sediba is not our ancestor, then we're left with these sort of hanging retroactive confessions of ignorance that are not actually resolved. The main paper reporting sediba said that the ancestry of Homo and its relation to earlier Australopithecines remain unresolved. Daniel Lieberman, talking about sediba, said from Harvard, said the origins of the genus Homo remain as murky as ever. And Donald Johanson, a famous paleoanthropologist who helped discover Lucy, said the transition of Homo continues to be almost totally confusing. So what we see in the fossil record is a Big Bang origin of Homo. The literature reports an explosion or rapid increase or punctuated change, an approximate doubling of brain size at the appearance of Homo around 2 million years ago. And a study of the pelvises of Australopithecines found very rapid evolution corresponding to the emergence of the genus Homo. Very rapid evolution means things are changing quickly in the fossil record without clear gradual change and evidence of how things changed. The paper I mentioned earlier in the journal Molecular Biology and Evolution said that Homo erectus or Homo ergaster, those would have been some of the earliest members of the genus Homo, which frankly were very similar to us in many important respects, that they were significantly and dramatically different from Australopithecines in virtually every element of its skeleton and every remnant of its behavior. The changes are sudden. No Australopithecine species is obviously transitional. They call it a, quote, radical transformation. In other words, a genetic revolution. So there's this genetic revolution leading to the first members of the genus Homo, which are radically different from the precursors in the Australopithecines. And in fact, this led this group of researchers to propose a, quote, Big Bang theory of human evolution. So this is not the language of gradual change where we see nice, neat transitional forms existing in the fossil record. In fact, 3 Harvard paleoanthropologists wrote a number of years back about what they call the bad news and the good news about the evolution of humans. And they said, this is the bad news. The transition from Australopithecus to Homo was undoubtedly one of the most critical in its magnitude and consequences. As with many key evolutionary events, there's both good news and bad news. First, the bad news is that many details of this transition are obscure because of the paucity of the fossil and archaeological records. In other words, we don't have fossils documenting this transition. So that's the bad news. So what's the good news? Well, they say, although we lack many details about exactly how, when, and where the transition occurred from Australopithecus to Homo, we have sufficient data from before and after the transition to make some inferences about the overall nature of key changes that did occur. So what's going on here is the fossil record provides ape-like Australopithecines before and human-like Homo after the supposed transition, but not actual fossils documenting a transition between these groups. And in fact, in absence of intermediates, we're left with what they call inferences of a transition based upon strictly the assumption of evolution. In fact, the great Harvard evolutionary biologist Ernst Mayr said that the earliest fossils of Homo are separated from Australopithecus by a large unbridged gap. How can we explain this seeming saltation or jump? He says, well, not having any fossils that can serve as missing links, we have to fall back on the time-honored method of historical science, the construction of a historical narrative. So I find this quote to be very significant in terms of acknowledging the large unbridged gaps between Australopithecus and the earliest members of the genus Homo. In fact, a 2015 review of hominin evolution in a Springer book by leading paleoanthropologists found that this problem is not just pertaining to humans. This problem of a lack of evolutionary transitions is found throughout the hominid fossil record. It says that the evolutionary sequence for the majority of hominid lineages is unknown. Most hominin taxa, particularly early hominins, have no obvious ancestors. And in most cases, ancestor descendant sequences, fossil time series, cannot be reliably constructed. So it's a problem throughout the hominid fossil record. And this is why in this photo I took it at the Maripang Museum, here's one I'll actually agree with to an extent. In the circles I've highlighted, the question marks, well, those question marks exist at all the nodes in this tree where species are branching off from earlier ancestors, okay? Those are all question marks. They don't know exactly what exists at the nodes of this tree, which led to the evolution of forms from previous forms. And I think that's very significant that the question marks exist precisely where the vast majority of the evolutionary change is taking place. Okay, so let's now get into the idea of human exceptionalism. Simon, how am I doing on time here? Do I have a couple more minutes? I'm going to take that as a yes. Can you guys hear me still?
Yes, so
okay,
that's a yes, Casey. Yeah,
okay,
that's a yes.
Good. Yeah. I want to make sure I wasn't frozen in space here across time and space and the internet. No. So, okay, good. We're still going. So let's go through human exceptionalism very briefly, since I was told I had an hour and I'm almost up to an hour. So what is human exceptionalism? Well, that is the view holding that the human race has unique and unparalleled moral, intellectual, and creative abilities, sort of that we're unique compared to the animals. So what are some qualities that make us unique? Well, obviously there's our language abilities, the fact that we make complex tools, our usage of fire, clothing, our ability to do abstract reasoning, mathematics, create music, poetry, and perform religion, and also engage in moral reasoning. These seem to be traits that are not found in other animals, and certainly nothing to the extent that they exist in humans. Now, some folks take a different view. I would say that what this shows is that human life is not just about survival and reproduction, that it has higher purposes. But the view that's being promoted at the Maripang Museum is encapsulated by this quote from Richard Dawkins. And this quote, this is a picture I took of the Maripang Museum, which it's actually a sort of a display that stretches from floor to ceiling. And they say, we are survival machines, robot vehicles, blindly programmed to preserve the selfish molecules known as genes. And just in case you didn't get it, that quote is actually repeated twice in the same room. Okay, here's the one that goes from floor to ceiling. It says, we are survival machines, robot vehicles, blindly programmed to preserve the selfish molecule known as genes. They don't want you to miss this quote. This encapsulates the materialistic view of human beings. In fact, what is this materialistic message? Simply put, it's that the purpose of human beings is nothing more than to survive and reproduce. We evolved, and we evolved to pass on our genes. Nothing more, nothing less. It's difficult to imagine a more materialistic message from a science museum. I really want to emphasize that. I've been to quite a few science museums over the years. I've never seen a more materialistic message than what is being promoted at Maripang through these quotes by Richard Dawkins, a leading evolutionary biologist and one of the world's leading spokespersons for atheism. So I would say the truth is, though, quite opposite. Rather than showing that humans are mere survival machines, the complexity of our DNA and the exquisite fine-tuning of our genetic code shows that it was put there by an intelligent designer for a purpose, and that our lives are not just about survival and reproduction. In fact, if there's any fact, any scientific evidence that refutes the claim that all we are just products of our selfless genes, it's the fact that genes exist to begin with. That in our DNA, we see a language-based code that produces molecular machines through a computer-like system of information processing. Well, where in our experience do things like language-based code, computer-like information processing, and machine-like structures come from? They have only one known cause, and that is intelligence. So selfish genes, I would say, refute themselves. But in any case, I just want to emphasize this materialistic message and how there's a lot more going on at some of these science museums than simply promoting the science. It's about promoting materialism to students. But thankfully, I don't think that materialism is true. Bioethicist Wesley J. Smith says that we humans are unquestionably a unique species. the only species of even capable of even contemplating ethical issues and assuming responsibilities. We are uniquely capable of apprehending the difference between right and wrong, good and evil, proper and improper conduct. So that is something that makes us stand out. What about our language abilities? Well, MIT professor and linguist Noam Chomsky says that human language appears to be a unique phenomenon without significant analog in the animal world. There's no reason to suppose the gaps are bridgeable. At the Maripang Museum, it said that there was this mutation in a gene called FOXP2 about 200,000 years ago that contributed to changes in our capacity for speech, influencing the development of language. Well, that is now no longer thought to be true. A 2018 report in the journal Nature found that this gene FOXP2 was thought to be what caused language, but analysis showed that it did not undergo changes in our recent history, and that previous findings from previous studies may have been false signals. And so it's no longer believed that this claim that the gene FOXP2 led to language that's promoted at Maripang is actually true. In fact, huge questions about the origin of language remain. A very prominent 2014 paper in the journal Frontiers in Psychology by leading evolutionary anthropologists said that studies in non-human animals provide virtually no relevant parallels to human linguistic communication and none to the underlying biological capacity. The most fundamental questions about the origins of evolution of our linguistic capacity remain as mysterious as ever. So many of you may have heard of this book, Sapiens by Yuval Noah Harari. It purports to explain everything about what has happened in the human race. And I want you to see the explanation that he gives in this book for the origin of human language. He says, the appearance of new ways of thinking and communicating between 70 to 30,000 years ago constitutes the cognitive revolution. What caused it? He says, we're not sure. The most commonly believed theory argues that accidental genetic mutations changed the inner wirings of the brains of sapiens, enabling them to think in unprecedented ways and to communicate using an altogether new type of language. He says it was a matter of pure chance, as far as we can tell. Well, we don't know why this cognitive revolution happened. He doesn't know where, when, or how those mutations changed our brains, but yet he's sure that it happened due to quote unquote pure chance. Is that a compelling explanation, or is he just assuming that it's pure chance? I would say he does not actually have an explanation for the origin of human language. He goes on to say that sapiens helped to foster what we call common myths, such as the biblical creation story, and that such myths give sapiens the unprecedented ability to cooperate flexibly in large numbers. So he's saying that, look, language allowed us to cooperate, and this allowed us to create myths, which allowed us to survive and reproduce better as a population. And he uses this to explain sort of the origin of human cognitive abilities and language and religion even, that all these things allowed humans to cooperate and then better survive and reproduce. And there was actually an interview on Justin Brierley's Unbelievable podcast earlier this year where someone said he lost his faith because he felt like this book explained how human language and religion evolved because it allowed us to cooperate and thereby better survive and reproduce as a species. And I'm sure he's true that shared beliefs and shared myths and language abilities and religion even do foster cooperation, which helps us survive and reproduce. But this is an observation, not an explanation. I would say that perhaps these shared myths, which foster friendship, fellowship, and cooperation among humans, did not result from pure chance, but reflect the intended state of a society as it was intended by a benevolent designer. And what he calls large-scale human cooperation might be a design consequence for a society with widely shared religious beliefs, not an accidental evolutionary byproduct. So I think that we can come up with different ways of explaining human cooperation. In fact, when we look at some of humanity's greatest achievements, we have Michelangelo painting the Sistine Chapel, Albert Einstein understanding the depths of relativity and the physics of the universe, or Oskar Schindler, who risked his life to save people from a different tribe, the Jews, during World War II, during the Nazi occupation. What we see is that human life is not simply about survival and reproduction, that we're meant for much higher purposes and much greater things than merely survival survival and reproduction. So the next time someone tries to break down the differences between humans and apes, remind them that it's humans who write scientific papers studying apes, not the other way around. So I'm going to close this up very quickly here, talking about the genus Homo and how the members of the genus Homo are all very similar. In contrast to the Australopithecines, the major members of Homo, such as Homo erectus and Neanderthals, are all very similar to modern humans. They're so similar to us that some have classified erectus and Neanderthals as members of our own species, Homo sapiens. And if you look at this comparison of skulls, yes, there are some differences, but those differences are very minor. And in fact, if you compare skull sizes of Australopithecines, Homo habilis, Homo erectus, Neanderthals, Homo sapiens, and modern apes, we see that they fall into two basic groups, and that even Neanderthals have an average skull size that is larger than that of modern humans, and Homo erectus, the average skull size, and actually their skull sizes are within the range of normal modern human genetic variation. So we could take a lineup of skulls and line them up from small to large. If you wanted to make the appearance of sort of an evolutionary progression of small to large skulls, you can be done. That can be done. You can do that. But the question is, what does that mean evolutionarily speaking? The reality is that brain size correlates very poorly with intelligence. Christoph Koch, president of the Allen Institute for Brain Science in Seattle, said that total brain volume weakly correlates with intelligence, and brain size only accounts for between 9 to 16% of the overall variability in general intelligence. So it's not the case that a lineup of brains from small to large skulls necessarily shows a gradual progression of the evolution of intelligence. If you want a good example of this, two of the great novelists of the 19th century, one was the French novelist Anatole France, and another was the Russian novelist Ivan Turgenev. Turgenev's brain was twice the size of Anatole France's brain, yet they were both celebrated novelists of the 19th century. So I don't think that brain size necessarily tells you exactly how intelligent a species is going to be. And in fact, a number of studies have said that internal brain organization is much more complex and important for determining intelligence than is the sole dimension of brain size. It turns out that Homo erectus may have been much smarter than we thought. I'm not going to go into too much detail on this, but basically they're finding Homo erectus fossils on isolated islands where it's thought that in order to get there, they would have needed to be able to build boats and use language in order to navigate difficult channels through oceans. So this anthropologist, Daniel Everett, says that basically Homo erectus had a very high level of intelligence and language, even though this isn't preserved in the fossil record. But in order to explain how they arrived at these islands, they had to be able to use language and build boats. Neanderthals are often thought to be sort of these brutish type individuals, but one anthropologist said they may have had heavier brows or broader noses or stockier builds, but behaviorally, socially, and reproductively, they were all just people. Another archaeologist says Neanderthals were using technology as advanced as that of contemporary and anatomically modern humans. They were using symbolism in much the same way. So contrary to popular perceptions and claims by some evolutionists, Neanderthals do not show that humans are descended from primitive and or ape-like species. In fact, we see in the fossil record morphological mosaics, which suggest that modern humans and Neanderthals interbred, and some people even have Neanderthal DNA. So what's really the difference between us and them? I would say that they were a subrace of human beings that lived in the European zone of the human race a few 100,000 years ago, and there's really no difference between us and them. In fact, a few years ago, there were some paleoanthropologists in France and Israel who created an exhibit showing a Neanderthal specimen, and the internet immediately said, well, that guy looks just like Chuck Norris. And this, of course, led to various Chuck Norris jokes. If Chuck Norris was a Neanderthal, he'd still be smarter, stronger, and more advanced than you. Or there is no theory of evolution, just a list of animals that Chuck Norris allows to live. Or Chuck Norris once kicked a horse in the chin. That's how the giraffe evolved. So there you go. So anyway, I would say that the differences between these human-like members of the genus Homo can be explained as microevolutionary effects of size variation, climatic stress, genetic drift, and differential expression of common genes, to quote one paleoanthropologist. These are microevolutionary differences between humans, Neanderthals, and Homo erectus. And I would say that intelligent design provides a better explanation for this abrupt appearance that we see in the fossil record. Stephen Meyer and others say intelligent design provides a sufficient causal explanation for the origin of large amounts of information. The intelligent design of a blueprint often precedes the assembly of parts in accordance with a blueprint or preconceived design plan. So when we see this abrupt appearance in the fossil record, that's best explained by design. So some take-home points. Hominid fossils generally fit into two categories: ape-like and human-like species with a large unbridged gap between them. This morphological discontinuity reflects a genetic revolution. The genus Homo appears abruptly in the fossil record in a manner that challenges standard Darwinian explanations for the origin of our species. And a Big Bang model requires the rapid origin of new genetic information, which is best explained by design. So I'd like to think that Chuck Norris would approve of this because he says, I believe in microevolution, genetic mutations that provide small variations in different species in the animal kingdom. But I don't believe those micromutations lead to macroevolution, large genetic jumps that turn one animal species into another, such as apes into humans. And all I can say is, well said, Chuck, not bad for a Neanderthal. So thank you very much. I'm going to cut it off at that and happy to take some questions.
Okay, thank you, Casey, for that awesome presentation. It was packed full of information, and I appreciated the humor at the end of that as well. But thank you so much for that excellent presentation. It's long overdue that we've been able to get something like this. It's been put together with somebody who is read in this field and certainly has visited the cradle of mankind as well here in South Africa. And maybe we can just start off with a few questions from my end here. I just want to recap then in terms of my visit to the cradle of mankind was the kind of standard evolutionary kind of story which you get as you walk through the exhibit and you go through the various parts of it, and then you go on the floating devices through these simulations where you kind of there's lights used and snow.
It's like Disneyland. You go back in time. Yeah,
I mean it's quite creative in that, but you can get the overall messages that you've got a state of affairs where there's just natural forces at work on nature, and then out of that emerges this DNA strand. But I just want to ask, is it fair to say that when it comes to the question of evolutionary theory, that to some extent the debate has shifted from discussions on fossil records and trying to find the missing gaps to really the question over how do we get an information system and questions of abiogenesis? Is it fair to say that that's where it shifted? Because it seems like it's a massive leap to go from showing a relationship between two hominids and going, therefore, evolution, because now we've got a lot of information on what's going on in the cell. It seems like it's a massive leap to just, bridge that conclusion with one big leap like that. Is it fair to say that that's where the debate is today?
Yeah, great question, Simon. And I think that for many of us in the ID movement who recognize the reality that information is running the show in biology, that is where the debate is at for us. And we're the ones who are asking these questions. Is there enough time allowed in the fossil record for these complex genetic traits to evolve in, say, less than 10 million years that are allowed by the fossil record since we supposedly shared our most recent common ancestor with apes? Okay, so it's the ID proponents who are driving these questions forward. That article in the journal Genetics that admitted that there was not enough time to even evolve a mere 2 mutation simultaneous trait in a population of humans, that paper was written in response to Michael Behe and David Snoke, 2 ID proponents who published a paper in the journal Protein Science and who were writing about this topic. So it's the evolution. We are the ones in the ID camp who are driving these questions forward right now, because we're the ones who are willing to ask the questions. Well, if information is running the show in biology, can you generate that information through a blind process, a blind trial and error process of random mutation and natural selection? Does not seem like a very efficient search mechanism to find those rare sequences that generate functional traits. Okay. And so we're the ones who are driving this question forward. But I mean, of course, the questions we want to look at all the evidence. So of course, the questions about the fossil record are important. But I think that the information question is really where the debate is going to go in the coming years. I want to piggyback off what you just said, if that's okay, Simon, to give a slide that I missed. So South Africa actually has quite a tradition of allowing us to consider intelligent design in human origins. And this comes from Dr. Robert Broom. This is a photograph I took of him at Meropeng. Meropeng does not acknowledge that Dr. Broom, who founded the field of paleoanthropology in South Africa, Meropeng does not acknowledge that he was essentially a proponent of intelligent design, but he was. And in fact, in a paper he wrote, he said that Lamarckism and Darwinism seem to fail completely, and one feels that mutation is quite out of the question if it is the result of pure accident, and only conceivable if an intelligent agency is behind it. This is from a paper that Robert Broom wrote in 1933. Can you believe that? How, when you're an intelligent design proponent, you're being led in the right direction, just because you're seeing that the complexity of life does not arise by random mutation and natural selection. Of course, this is before they even understood how the mutations were changing DNA, but they had an idea of mutation. They knew that mutations occurred in some kind of a genetic molecule. They just didn't understand how it worked. But they could see even then that random mutation was not going to do the job. In his book, The Coming of Man, was it accident or design? I mean, that book could be written today. Robert Broom said, one feels driven to the conclusion that some intelligent power has played a part in the evolution. Many see nothing in it but a succession of fortuitous mutations, which by the selection of blind forces of nature have resulted in the evolution of a Shakespeare and a Newton from a fish. I fancy I can trace intelligence behind it all. Wow. So Robert Broom, who literally founded the field of paleoanthropology in South Africa, people aren't going to like me saying this, but he was a proponent of a view that is very difficult to distinguish from the modern theory of intelligent design. Okay. When it comes to how complex traits arise. Yeah. So I think, look, and intelligent design theory allows for the possibility that humans and apes shared a common ancestor. Okay. Now I'm a skeptic of that for reasons we just discussed from the fossil record, but I think Robert Broom probably would have accepted that humans evolved from some kind of an ape-like creature. That's fine. But he sees that the mechanism of that evolution is not going to be blind and random and unguided mutational processes being acted upon by blind natural selection. Okay. So I would love to see South Africa's rich and highly productive and world-class tradition of paleoanthropology return to its roots and consider the possibility of intelligent design.
Brilliant. That's very good. Those are great quotes there from Robert Broom, and important for South Africans to be familiar with that, given his gravity and significance in the field here in South Africa. I want to return also to Homo Naledi and Sadiba. If you could maybe just revisit and unpack it for us, because I remember when these discoveries were made and they came out in the paper and there was a lot of excitement about them and all the rest of it. But then again, it took a while for the dating to happen. In fact, I remember having this conversation with Sue, because she says that at the stage that we visited with her, they were still trying to get the dating on it. So am I correct in saying the problem with both of these discoveries is both of them are just too recent to be of any significance? Had they been 2 or 3 million years old, then there would have been an interesting discussion then. But the dating of both of these is just too recent, and so what we just end up having ostensibly is just more questions in the tree rather than any solutions to this explanation.
Yeah, I mean, they're definitely significant fossils in that they're telling us some fascinating new information about species that have lived in the past and that lived at those time periods. But yeah, they're not significant as far as explaining human ancestry, because they could not have been ancestors to our genus Homo. Australopithecus sediba appears about 800,000 years after the genus Homo, and Homo naledi appears some 2 to 2.5 million years after the genus Homo appeared. So, and certainly, basically Homo naledi was contemporaneous with individuals that would have been very, very difficult to distinguish from you and me.
Okay.
Nice bald heads there, Simon. They would have looked.
Yes,
Who knows what they look like?
with
Yeah.
large brow. Although I would probably say in the Neanderthal category.
Yeah.
With
Well, you got the brow going, but I mean, I'm going to be there in a couple of years. So give me a couple of years here.
Yeah. No, for sure. I think that was fairly significant as well. I also, when we were visiting with Sue, I know that her expertise was in, as I understand, teeth, which is a very important part because you can tell a lot from the study of the teeth. And so, but I really got an appreciation for, as she carefully went through and she discussed aspects of this bone structure to point out to me, you see this aspect of the pelvis and you see this aspect of how you walk. It was very significant for her to point out all these aspects of the anatomy, what they could derive from these things, and how many changes would be required to move both Sadiba and Naledi to walking, for example. So I just want you to maybe just revisit that again as well, to talk to us about, because I mean, at a superficial view, when you see something with a skeleton of an ape, you can see kind of, and a skeleton of a human being, you can see arms and legs, and you can see, so to the uninformed, it looks, oh, well, that's a fairly easy process, until you actually understand, no, you don't understand, but to move from feet that can walk, and that is actually, there's significant changes required. Maybe just revisit that though, because I think it's a very important part to say that to the uninformed, it just looks like there's an easy connection between the two, but actually it's not as easy as that.
Yeah, so that paper I quoted from the journal Nature by Bramble and Lieberman talks about all these different features that are different between humans and Australopithecines or other ape-like species. And they talk about what would be necessary to basically convert an organism like that into a human being. And you would need a number of changes. I mean, they talk about a new design of the spine, a new shape and tilt to the pelvis, legs that angle in from the hips, knees, feet, and toes that are retooled, a skull that sits on top of the spine in a balanced position. And a lot of these changes, you can't just change one thing. You change the pelvis. Well, now, the organism can't look straight ahead. So you have to change the tilt of the head, as it comes out of the spine. That requires a whole new design of the spine and the skull. And it also requires changes to the femur and to the knees. And so you change, and also to the feet and the toes. So you change just one trait of these organisms, and that's going to actually probably give them all kinds of, they need to go see an Australopithecine version of a chiropractor or something. Maybe they had one guy in the tribe who would, rub everybody's back. I don't know, but basically, it's going to screw things up. You need to have what we call coordinated changes. If you want to convert an ape-like creature into a human-like creature, you can't just change one trait. You have to change multiple traits at a time, or else you're going to screw things up. And so there was a good example. Just talk about getting a larger brain case. There was a news story I read years back that said, well, we found a mutation that allows for jaw muscles. We found a mutation that allows for the brain case to potentially get bigger. And they were saying, well, maybe we've solved how intelligent, beings evolved. Well, I'm sorry, but making a bigger brain case is not enough to just give you a smarter brain. As we talked about, internal brain organization is what gives you a smart brain. You can have two people with very different sized brains. Those two 19th century novelists, one had a brain that was twice the size of the other, and yet they're both very intelligent. So it's the internal organization that makes the difference there. But let's just say that all you needed to do was get a bigger brain, all right? Well, do you just need one mutation to enlarge the brain case? No. This article then quoted one paleoanthropologist who said, well, look, that's fine, you can get a bigger brain case, but that alone is going to screw things up, because your jaw muscles attached to your skull. So if the brain case gets bigger, then you're not going to be able to talk, because your jaws won't be able to open, because you're going to stretch your jaw muscles out. So you need to also have a simultaneous set of mutations to retool cool your jaw muscles, maybe loosen them or change the way they're attached to your skull, whatever it is, to change them so that now you can open your mouth and talk and eat properly. Okay. So again, just a simple change, you would think, like getting a bigger brain, but let's just say a bigger skull case, would require a suite of multiple coordinated changes. And again, if any two mutations were needed before some advantage is conferred upon the organs, and according to the Darwinian math, though that type of change is unlikely to occur in the 10 million years since we shared our common ancestor with apes. So I think, just mathematically speaking, Darwinism faces an insurmountable problem here. The fossils just confirm what the math is already telling us. We don't see this gradual evolution.
Okay, brilliant. We do have a few questions here for you, and for you, Dr. Luskin, could you elaborate on your statement that Neanderthals are a subrace of human beings, not much different than us?
Sure. So that's the way I see it. I want to acknowledge that both within the mainstream paleoanthropology community and even among Christians, there are different views about the relationship between Neanderthals and modern humans. In both groups, you see some folks who say, "Oh, these are basically very little different from us, and we can consider them to be just another group of humans that lived at one point." And then there are people who say, "No, this is a totally different species. They didn't interbreed. They were genetically distinct from us. They're totally different." You see folks within paleoanthropology and within, sort of the Christian community who will have both views. So I hold what I'm about to say very open-handedly, all right? Whether we interbred with Neanderthal, whether we actually are the same species as Neanderthals, doesn't make that big of a difference to me. Either way, what Neanderthals are not is they are not some kind of non-human-like primitive evolutionary precursor to humans. Okay, whatever they were not some primitive non-human-like evolutionary precursor. All right, but what I would say is, my view is that they're so similar to us morphologically, both above the neck and below the neck, that I think that they probably were just a subrace of human beings. And when I say human beings, I mean our species. Our species exists today, but it also existed in the past. And maybe in the past, there were various subraces that lived in certain parts of the world that would have been no less human than you or me. But they left a slightly distinct fossil record. They had a bun at the back of their head. They had slightly thicker brow ridges. They're a little bit stockier. You can find people among modern humans today that have those traits. In fact, there's good evidence from both fossils and DNA that those quote unquote Neanderthals interbred with modern humans. Well, that's just the way we frame the question. That's assuming that we are a different species. It might be that we are us and they are them, and I actually have a friend who just did 23andMe. He's a very prestigious biologist here in the United States, but he's undercover. He's one of those many ID proponents that can't be public about his views or he'd get in trouble. But let's just say he's some of the highest levels of research in the US, especially in the US government for science, for biology. He did 23andMe, got his DNA sequence, and he said, you know what? Turns out I'm part Neanderthal, which makes sense because he has a lot of German ancestry. And he looked at the way that the DNA was contained on the chromosomes, and he says, this DNA looks like it has been preserved for a very long time. Isn't that interesting? This suggests that this is just part of human history. This DNA is just a little package of DNA that has been, some people have DNA from East Asia. Other people have DNA from Africa. Other people have DNA from Europe. His DNA happens to have these sort of signatures that are it's a little package of DNA that did not get changed through recombination. And it suggests that this Neanderthal DNA has been around for a long time within the human lineage, but it's not. When I say Neanderthal, you could see it as saying, I don't know, German DNA or Norwegian DNA. I mean, I'm making that up, but you could also just use a term like that. And it's just a group of people that were around, and we bear their evidence that they were our human ancestors. So that's just one way to look at it. And I know that some Christians take a different view, and that's okay. I hold this open-handedly. I could be wrong, but I see no incompatibility between that view.
Okay, excellent. Another question for you. What fossil, in your opinion, is the earliest human fossil we have to date that you know of?
That's a good question. Well, I mean, I think that there are Homo erectus fossils that date to about, say like 1 million years ago. Turkana for example. I think he's a little over 1 million years old, that are very similar to us. I mean, below the neck, we're talking about fossils that are virtually identical to us. So let's see, Turkana was 1.5 million years ago. And below the neck, these species, these individuals are virtually impossible to distinguish from us. They did have slightly smaller brain sizes, but again, like I said, even Homo erectus was within the range of modern human genetic variation. We don't know for sure that they were really that unintelligent. We're finding erectus fossils on these islands where they had to use boats and language to get there. Those kinds of things don't fossilize very easily. So there's just a lot we don't know about these species because it was not preserved.
Okay. Is it good?
So I would say, look, well, Simon, let me say, I don't know exactly when the first quote unquote modern human arose. I personally am a Christian, so I do believe, not on scientific, but on theological grounds, that we are descended from Adam and Eve. And I don't know exactly when they lived. Okay. I don't really think that there's any timeline for me on that. Yeah.
Okay. Is there good reason to think that the missing link would not be found in the future?
Well, you have to be open to whatever's found. And first of all, many paleoanthropologists will be quick to tell you, oh, well, in the scientific community, we don't use the term missing link. So don't use that term. They'll sort of correct you in this condescending manner. I don't use the term missing link, but I will say this, you can find the term missing link in the scientific literature all over the place. So when you have sort of these snooty evolutionists saying to you, don't use the term missing link because scientists don't use that term. Well, that term is used throughout the literature. It's kind of used. It's just a fun little colloquial term, but I don't typically use that term. But anyway, look, you have to be open to whatever is found in the future. And maybe we will find fossils that bridge those gaps between the ape-like Australopithecines and human-like members of the genus Homo. That's not going to change the Darwinian math, okay? The Darwinian math is still going to be there, causing a huge barrier for the Darwinian evolution of humans, the evolution of humans through an unguided and blind process of random mutation and natural selection. Okay, so, maybe Robert Broom is right. Maybe we did evolve from ape-like creatures. I don't think the evidence supports that, but Robert Broom would say we evolved from ape-like creatures, but it was a guided process. It was not an unguided evolution. The mutations were not random or accidental. It was guided, and if you're a believer in a theistic religion, you could say, well, it was guided by God, maybe, to produce human beings. So it's no longer really a blind mechanistic evolution of human beings, if you want to take that view, which is certainly very compatible with the ID viewpoint. I personally don't think the evidence supports human evolution from ape-like creatures, but maybe I'm wrong. I hold this open-handedly. That's the great thing, by the way, about being an ID proponent. Okay, I can have the freedom to follow the evidence where it leads. And if the evidence points in the direction of intelligent causes, I can follow the evidence in that direction. If the evidence points in the direction of material causes, I can say, okay, fine, this was the result of mutation and selection. But if you're a materialist, you don't have that openness to what the data actually is saying. You have to have nothing but material causes all the way down, not just through the evolution of humans, but the evolution of all other organisms back to the origin of life, back to the origin of the very universe itself. And then at that point, I don't know what you do. I don't know how you account for material causes all the way down to the very beginning. But as an ID proponent, we have freedom. We can follow the evidence where it leads. It's a much more open scientific philosophy that allows us to actually see what the evidence says without having to stick to some sort of predetermined narrative or predefined answer about what the evidence has to show. The evidence could show material causes, but they could also show intelligent causes, and I'm free to follow the evidence where it leads.
Brilliant. Well, thanks very much, Casey. And we do thank you for your time and your responses. And we hope to interview you in the future on all kinds of interesting topics that you and the Discovery Scholars are doing. But just in closing then, thanks again for doing this lecture for us and having the content. I think it's important for us as Christians to be somewhat familiar with these things. But yes, I really appreciate that. And we look forward to chatting in the future with you. Do take care.
Thanks a lot. I just want to say thanks for letting me go on and on for an hour and a half here. And I want to say just to my friends who are maybe in the paleoanthropology community to be open to material causes and or to be open to intelligent causes in addition to material causes. And I just want to say that I miss South Africa greatly, Simon. I love your country. And I know you guys have had a rough time the last few months. You guys are in my heart, my thoughts, my prayers. And I wish you guys the best. Can't wait to come back.
Excellent. You take care. Thanks very much.
Okay. Bye-bye.